Now projectile assignment question 2. Okay, 2A. State two assumptions that you usually make in solving a projectile motion problem near the surface of the Earth. Right? So these are we give you three assumptions, right? Okay, number 1, gravitational field strength is constant. Number 2, the effect of air resistance is negligible. And number 3, the rotation of the Earth does not affect the motion. Let's look at 2B. In 2B, it is interesting. There is a hunter, right? 2B. Okay, there is a hunter hunting, and he has this velocity v, right? Thus, he has a horizontal component, and he has an angle theta. Okay, he has a horizontal component of cosine theta v, right? And a vertical component of v sine theta. Okay, notice I use dotted line. Okay, because these two dotted line is actually when you resolve v into the vertical and horizontal component. Okay, now there is a target. Okay, there is a target with u initial speed in the y direction equal to 0, and it's dropping down. Okay, now B part 1, it asks us write down the expression to show the vertical and horizontal displacement of the projectile, which is the projectile here, at the point of collision. Okay, first we must define, let t be time of collision. So t, okay, let's put it t prime. Okay, so t prime is the time of collision, right? So in part 1, right, for the projectile itself, horizontal displacement, right, will be equal to v cosine theta, right, multiplied by t prime, right, because it's a constant speed horizontally. Now, vertical direction, right, taking upward as positive. Okay, we use s equal to ut plus half at square, right, where u y, okay, is equal to here. Okay, I'm taking up as positive, right? So this is a positive value. It's v sine theta. Okay, this is minus 9.81 because it's pointing down for gravitational field strength, right? Now when you sub these values in, you get v sine theta t minus half 9.81 t square. Okay, so this will be your answer. Let's look at part 2, right? How about for the projectile? At the time of collision t prime, where will the projectile be, right? The projectile is actually coming down, right? So we know that it's coming down, so we take downwards as positive, right? Taking down as positive, okay? Again, the distance s, okay, there are two sy now, right? This will be sy 1, okay? It should be here. Okay? sy1 here. Okay? And let this be sy2. Okay? Let this be sy2. So sy2 is equal to ut plus half at square, right? Taking down as positive. It doesn't have any initial velocity downwards, so this is 0 multiplied by t, right? And you plus half 9.81 t square, so you get half 9.81 t square. Okay, this is the distance sy2. Okay, now if you look at this diagram, okay, this the hunter is really aiming at the projectile, okay, right from the start, okay, and we know that the horizontal distance is horizontal displacement from time of collision is going to be v cosine theta t, okay. So we actually have this in part 3, right? You have this distance v cosine theta t, okay, and you know this is theta, right? So this is the direction of v, right? It's aiming at the target, okay. So what is this distance? Sy prime, for example, right? We know that sy prime divided by v cosine theta t, the horizontal displacement, must be equal to tangent theta, right? So sy prime must be equal to this tangent theta becomes sine theta over cosine theta, right? Multiplied by v cosine theta t, right? These two will cancel off, okay? That will give you v t sine theta, okay? So for the two projectiles to meet, we can put it here, right? For not two projectile, for the projectile to hit target, right? So I'll say that sy1 plus sy2 must be equal to sy prime, right? Okay, sy1 plus sy2 equal to sy prime, which is equal to, right? So let's look at the left hand side, which is sy1 plus sy2, right? I already have my sy1 and sy2, okay? This is my sy1, okay? This is my sy2, right? That will be equal to, look here, right? I already have my sy1, which is v sine theta t minus, right? So I write v sine theta t minus half 9.81 t square, okay? And then add to sy2 plus half 9.81 t square is equal to, right, which is equal to right hand side, proven. So that's how you do it.